Okay, so today you are going to learn the first subtopic, that is systematic nomenclature under the chapter 4. So these are intended student learning. Okay, you can read them by your own self. Okay, I'm really hope that at the end of this topic, okay, you can read you can give the systematic name of the organic compound, okay, or you can draw the organic compound. Organic compounds means they are carbon containing compound. It also has a covalence of 4, means it can form 4 covalence bonding. We know that in organic compounds, they have a carbon containing compounds. Thus, it can form 4 bonds. Due to the stability carbon atoms in the organic compound, we can say that the carbon itself is a tetravalent. The tetravalent actually comes from the tetrahedral shape like this. In organic compound, other elements may also be present. Okay, for example, nitrogen, oxygen, sulfur, phosphorus, and halogens. This kind of D atom, we call it as a heteroatom. In organic compounds, there are 2 structural features that you need to know. The first is hydrocarbon change or ring that is nonpolar, and unreactive if it is saturated chain. Saturated chain means only the single bond in the organic compound. The second features in the organic compound is one or more functional group in the organic compound. For example, hydroxyl or amine group. So this is the shape. The structural of the hydroxyl OH. And amine group NH2. We know that the functional group is a very reactive, thus it can undergo the change in chemical reaction and also influence the physical properties of a compound. Let's take a look the bonding of the carbon atoms. We know that carbon atoms have a tendency to covalently bond with other carbon atoms and form chains. It can be a straight chain, like this, branch chain, or ring chain. In the organic compound, carbon atoms can engage in a single, double, or triple covalence bond with other nonmetals. You may find that there are saturated organic compound, means in organic compounds there is only single bonds in the saturated compounds. How about for unsaturated compounds? Means it contains at least one double or triple bond. So a double bond, for example, like this, C double bond C, triple bond C, triple bond C. Before you proceed to know more about the how to give the systematic name for the organic compound, let's look at some terminology of basic organic chemistry. The first one, molecular formula. Molecular formula means it represents the number of each atom in a molecule of any element or compound. For example, butene. So the general formula of butene is CnH2n. CnH2n. Please do not confuse with the butane. So look at the molecular formula of butene here. Butene has a 4 carbon and 8 hydrogen. The subscript of number of the molecular formula shows the number of atoms. Next, empirical formula. Empirical formula represents the simplest whole number ratio of compounds in compound. of a ratio of atoms in compound. For example, okay, we know that butene, okay, the empirical formula of butene is a CH2. So CH2 is the simplest whole number ratio of atoms of butene. Okay, next, structural formula. Structural formula shows the individual atoms in molecule and how they are arranged. For example, butene again, okay, structural formula of butene means you show the individual atoms, okay, in the butene here. Okay, so means you open all the bond between the atoms. Next, condensed structural formula. Condensed structural formula means it is an abbreviated formula which shows the arrangement of the atoms in a molecule by means of groups of atoms. Okay, for example here, okay, CH3, okay, CH or CH3, okay, or else you can give it, okay, in like this, CH3, CH3. Alright, you means you condense the atoms. Okay, stick or lines, okay, is a very simple. I prefer to draw in stick or line. Okay, in stick or lines, okay, usually functional groups are written out. Stick or line means you hide the carbons, okay, and also hydrogen atom. For example here, okay, so 1 2 3 4 5 6, so 6 butanoic acid. Okay, each dot here, okay, dot here represent the carbon. Okay, each carbon here, okay, we know that carbon must have 4 bonds. Okay, so here 1 2, so means it hides another 2 bonds. So another 2 bonds here is hydrogen. Okay, hydrogen. Same goes with other dot. Okay, for the next dot here, for the next carbon here, so means there are another 2 hydrogen atoms. So that's why we call it as a stick or line, means we hide the carbon or hydrogen atoms. Same goes for this one. Okay, so 1 2 3 4, so butene. Okay, so if you notice here comes from this one, from the structural formula. So each dot here represent carbon. Okay, 1 2 3 4. Okay, so and there is a double bond between carbon, the second carbon and the third carbon. Same with this one. Okay, second and the third carbon. Okay, next, the structural isomer. Structural isomer means molecule with the same molecular formula but different structural formula. For example here, okay, so if you notice here, this is butene. Okay, so the second organic compound is also butene, but the arrangement of the functional group is different. Okay, if you count the total number of carbon, both are same, C4. Okay, same goes with the hydrogen. Okay, hydrogen 3 plus 3 6, 6 plus 2 8. Okay, same goes with the second organic compound also. There are 8 hydrogen, but the difference is, okay, the arrangement of the functional group. The first butene here, okay, butene, the carbon bond is located carbon, second carbon. Okay, but for the second organic compound, the first functional group is located the first carbon. Okay, next, homologous series. Homologous series means, okay, it conform to general formula, have the same functional group, behave similarly in chemical reaction, okay, but different physical property, have a different physical property. For example, okay, look at the alkanes. So this is general formula for alkanes. If you notice, okay, all the alkanes have the same general formula. For example, you have a methane, ethane, propane. Okay, all these kind of organic compounds have the same general formula. Okay, but different physical properties. Okay, if you notice, hexane is a liquid, butane is a gas, so means different physical properties. Next, okay, the saturated compound. Saturated compound means there's no multiple bond. Okay, no multiple bond. For example, double bond and triple bond. Example of saturated compound is alkanes. Okay, next, unsaturated compound means it must has at least double bond or triple bond in a chain or ring. For example, alkenes, okay, and alkynes, okay, as well as unsaturated triglyceride that you will learn, okay, later. Next, aromatic compound. Aromatic compound means, okay, the benzene ring. So this is benzene ring form part of molecule, or you can draw like this. Okay, so the bond, so there are 3 double bonds. Okay, for example, methyl benzene, or the common name is toluene. Okay, next, how to give name for the organic compounds. Okay, we follow the IUPAC, that is an International Union of Pure and Applied Chemistry. Okay, so for me, I prefer to use the formula PPS. Okay, PPS, what does it mean? Okay, in other words, P S means, okay, prefix, parents, and suffix. Okay, so take a look at the simplest homologous series, that is alkanes. Okay, so these are the steps, okay, that you need to know. The first step is you need to find the longest carbon chain, so that is parent, and add the suffix, okay, the name ending or the functional group. Okay, next you need to identify the alkyl groups that attach to the parent chain. Okay, next, okay, you need to number the position of the alkyl group. Okay, and it must be started on the lowest number carbon possible. If there is a prefix di, tri, tetra, and etc., okay, you have to ignore these prefix when you want to give the systematic name. Okay, the prefix di, tri, tetra, and so on indicate the number of the identical branches. Okay, and last step is you have to arrange, okay, the side groups in alphabetical order. Okay, and ignore, okay, the prefix as I mentioned just now. Okay, for example here, the first step is you need to find the longest carbon chain. So this is the longest carbon chain here. Okay, I prefer to use this formula P